Good morning, students. The last class we discussed about the three-phase circuits or polyphase circuits. That is nothing but what is the three-phase system, and what is the balancer system or symmetrical system, how the three-phase will be generated in the generation and transmission system, what is the phase and what is the phase sequence, what are the advantages of three-phase system or polyphase system. Then we go for the important topic, that is relation between the phase voltage and line voltages in star and delta connections individually. That is the most important question. Now, today class we discuss about the measurement of power. Measurement of power by using 2 wattmeter method. This is also important topic in this section. So power calculation in three-phase system generally. Wattmeter is an instrument. Generally, to measure the power is nothing but we are using instrument is wattmeter. That means wattmeter is an instrument which is employed for measurement of power in any circuit. That is, a wattmeter has a current coil. Wattmeter having two coils. One is current coil, which is connected in series with the load, and another one is voltage coil or pressure coil that may be connected across the load, right? The pressure coil should carry the current proportional to the voltage across the load and in phase with the voltage. In order that the current through the pressure coil in phase with voltage, the circuit should be purely non-inductive, and hence it is a high resistive and is always connected in series with the pressure coil. That means resistive load, UPF power factor. The deflection in the wattmeter is proportional to the two currents through the coils and the cosine angle between them. Right? So the deflection of the wattmeter is proportional to the two currents through the coil and deflection between them. In order to measure the power in a three-phase circuit, we employ 1 wattmeter in each phase, and the sum of 3 wattmeters reading will give a total power. We have 3 phases, R phase, Y phase, B phase. For each phase we are giving 1 wattmeter. That means taking the total power is equal to sum of these 3 wattmeters reading, right? Suppose before going to the power measurement by using single wattmeter, 2 wattmeter method, we just measure the powers, different types of power, that is active power, reactive power, total power, right? So apparent power. Active power per phase is nothing but V phase, I phase, cos pi watt per phase. Total active power is nothing but, so 3 phases is nothing but 3 V phase, I phase, cos pi watts. Per phase, VI cos pi, V phase, I phase, cos pi. For active power for 3 phase system is 3 V phase, I phase, cos pi watts. Now calculating the reactive power per phase. Reactive power per phase is equal to V phase, I phase, sin pi, where per phase total reactive power is 3 V phase, I phase, sin pi, where. Total apparent power, that is volt amperes per phase, is equal to V phase, I phase. Suppose total volt ampere is 3 V phase, I phase, volt ampere. So active power, reactive power, apparent power. 3 vi cos pi, 3 vi sin pi, 3 vi, right? So now expression for voltages in terms of line voltage and line current, star or delta connection. So this is for this may be utilized for the two, useful for 2 marks and also problem solving the problems in 3-phase balanced system. We must remember the relation between line and phase voltages, line and phase currents in star connection as well as delta connection. In star connected system, line voltage is equal to root 3 into phase voltage and line current is equal to phase current. Coming to the for delta connected system, line voltage is equal to phase voltage, but line current is equal to root 3 phase current, that is line current equal to root 3 phase current. Now, by using this in star delta connection, you have to calculate the total active power, total reactive power, total apparent power. Total active power is equal to root 3 VL cos pi. Why? Because here we know the line voltages. Line volt, that's why root 3. Suppose in terms of phase voltages, 3 V phase I phase cos pi. But coming to the line voltages, root 3 VL cos pi. Why? Because line voltage is equal to root 3 times of phase voltages, right? Therefore, phase voltage is equal to line voltage by root 3. 3 by root 3, it is nothing but root 3. So, total active power is equal to root 3 VL cos pi. Total reactive power is equal to root 3 VL sin pi. Now, total apparent power root 3 VL. Like this, we have to calculate the total active power, total reactive power, total apparent power in the star delta connections. So in our syllabus only balanced system is there. Suppose we go for the unbalanced system, how can you calculate the total active power and reactive power, apparent power? Sometimes they ask me problem also. That's why we have to put into the slide. For star connected system, voltages are different. VL is equal to root 3 V phase. Line voltage is equal to line current is equal to phase current. Therefore, total active power root 3 VL cos pi. Reactive power is root 3 VL sin pi. And apparent power is root 3 VL, right? Unbalanced delta connection, IL is equal to root 3 I phase and VL is equal to VP. Total apparent power is root 3 VL, active power is root 3 VL cos pi, and total reactive power is root 3 VL sin pi. Now, mainly measurement of power in a 3-phase 3-wire system, that is 3-phase balanced system. First, here 2 methods will be there. So, two main first method, one wattmeter method. That means to measure the power by using single wattmeter in a 3-phase balanced system. Single wattmeter. If W be the wattmeter connected its current coil in one of line and a pressure coil between that line and neutral point as shown in figure. Look at the figure. This is the wattmeter. It consists of main, line, common, voltage. So line is connected to the line connection of current coil connection is connected in series with the line. And the pressure coil is connected, this is the pressure coil, is connected in between the line and neutral point as shown in figure clearly. The reading of wattmeter gives power per phase. Therefore, total power is equal to per phase, that's why 3. Suppose line voltage is root 3. So total power is equal to 3 into wattmeter reading, that is equal to 3 W values. Suppose we have to calculate the power by using 3 wattmeter method. Look at the figure clearly. So each and every line we are having 1 wattmeter. Now total power is equal to sum of these 3 wattmeter readings, W1 plus W2 plus W3. So in order that each current coil of wattmeter should carry the same current and that is passing through each load impedance, the current coil should be connected in series with the load impedance as shown in figure. For star connected load, the pressure coil, this is the pressure coil of wattmeter should be connected to the star point of load, which may not always be accessible. If it is not accessible, the terminals of pressure coil of 3 wattmeters are connected at a common point. Look at the figure. Pressure coil of all wattmeters are connected to one common point. That common point is called neutral point. Look at the W1. W1 pressure coil is connected to neutral point here. W2 pressure coil is connected to here. W3 pressure coil is connected to here. That means all the wattmeter pressure coils are connected to one common terminal. The terminal is called neutral point. So current coil of wattmeter is connected to R phase. Current coil of wattmeter 2 connected to Y phase. Current coil of wattmeter 3 connected to B phase. And this method of measurement of power is not practically employed. To overcome this difficulty, we will employ 2 wattmeter method of measurement of power, and 2 wattmeter measurement of power is very reliable and accessible. What is the main difference between 1 wattmeter method and 3 wattmeter method? Means like in 1 wattmeter method, where the wattmeter is connected in one phase. In the 3 wattmeter method, it is connected to all 3 phases. However, there is one difficulty in this type of connection. Sometimes it is not possible to have access of neutral point in the star connection. However, it is not easy to make the connection into phases of delta connected load. Total power is nothing but, as you said, that total power measured by using 3 wattmeter method is equal to sum of reading of all these 3 wattmeters, W1 plus W2 plus W3. The 3 wattmeter method can be used for star and delta connected for unbalanced load also. So this is the most important one. So 2 wattmeter method. This method is commonly used for power measurement of 3-phase circuit. To measure the power in 3-phase circuit is nothing but nominally you can say that by using 2 wattmeter method. That is the benefit of this method. Very important, and it gives the better result compared to the single wattmeter and 3 wattmeter method. This is the most common used method for measurement of power in 3-phase system. This method can be employed for balanced systems as well as unbalanced systems, for star connected or delta connected 3-phase circuits. In this section, we will show that 2 wattmeters are sufficient to measure the total power in a 3-phase system if they are connected as shown in figure. Look at the figure clearly. So to measure the total power, we have to connect only 2 wattmeters. So let us consider a 3-phase star connected load impedances of ZR, ZY, ZB, and the 2 wattmeters are connected to measure the total power. The current coils of wattmeter 1, W1 and wattmeter W2 are connected to lines of R and Y. The pressure coils of W1 and W2, so the pressure coils of W1 and W2 are connected to the another phase, that is B phase. Connect to the lines RB and YB. The current coils of W1 and W2 connect to the lines R and Y. Pressure coils are connected to the RB, YB, right? RB and YB. The name suggested, that means only 2 wattmeters are used. The current coils of 2 wattmeters are connected in connection series on the any 2 lines, and the third line on which no wattmeter is connected. The 2 wattmeter used for measurement of power in 3-phase system irrespective of the loads, that is it may be balanced load or unbalanced load. Let VRN and VYN and VBN be the phase voltages across the 3 loads, and IR, IY, IB be the phase currents respectively. Let us consider phase voltages are VRN. VYN and VBN. Similarly, phase currents are small IR, small IY and small IB. Thus, the total instantaneous power VRN into IR plus VYN into IY plus VBN into IB. To find the power measured by the wattmeters of W1 and W2, the instantaneous values of the current flowing through the current coil of wattmeter 1, W1 is equal to IR1. Now, therefore, instantaneous voltage of the pressure coil of W1 is ERB. Similarly, ERB is equal to VRN minus VBN. Now, the instantaneous power measured by W1, ERB is equal to W1 is equal to IR into VRB, that is equal to IR into VRN minus VBN. Similarly, power measured by wattmeter W1 is equal to IY and instant voltage W2 is equal to EYB. Therefore, EYB is equal to VYN minus VBN. Total instantaneous power of wattmeter 2 is IY into EYB, IY into VYN minus VBN. Now, the sum of two powers measured by the two wattmeters W1 plus W2 is equal to IR into VRN minus VBN plus IY into VYN minus VBN. Therefore, IR VRN plus IY VYN, IY VYN. So, IR VRN minus IR VBN plus IY VYN plus IY VBN. So, now that may be represented as IR VRN plus IY VYN minus IBN into IR plus IY. Apply KCL at node N, that is nothing but star point. We get, look at the figure. Apply KCL at node S, that is that star point we are getting. So, look at the figure. IR is the incoming current, IB is the incoming current, IY is also incoming current. That means all three currents are incoming to that point, common point N. Apply KCL at node N. So, the three currents are incoming. Therefore, IR plus IY plus IB equal to 0. As usual, this is a three-phase balanced system. That's why three currents are equal to 0. Therefore, IR plus IY plus IB equal to 0. That means IR plus IY is equal to minus IB. IR plus IY plus IB equal to 0. Therefore, IR plus IY is equal to minus IB. Putting the values of IY plus IR is equal to minus IB in the equation, in the above equation, W1 plus W2 equal to IR into VRN plus, in place of IY we are putting IY into VYN into, in place of IR plus IY we are putting minus IB. Therefore, so W1 plus W2 is equal to IR VRN plus IYN IY into VYN plus IB into VBN. So, W1 plus W2 is equal to product of each phase voltage and phase current. That means VRN IR plus VYN IY plus VBN IB. That means total instantaneous power W1 plus W2 is equal to total instantaneous power. Now, first equation. So, this is this equation taken as equation 1, total instantaneous power, and the last equation, so this one, W1 plus W2 is equal to VRN IR plus VYN IN plus VBN IB. So, are identical. So, both are identical. Therefore, the sum of two wattmeter reading gives the total instantaneous power Actually, the power measured by each wattmeter varies instantaneous to each. The power measurement by the each wattmeter varies instant to instant, but the inertia of the moving system makes the point to read the average power. To read the average power. The above proof does not assume a balanced load or a sinusoidal waveform, hence it is applicable to under all conditions. That means it is applicable to under balanced conditions as well as um, unbalanced conditions. This is also very important. Section B theory part is completed. Section A theory part is also completed, that is transformer. And section B three-phase circuit is also completed. Now next class we discuss about the problems, section 1 and section 2. So generally this is the most important topic. Explain the measurement of power by using 2 wattmeter method, right? So this derivation will be done, and derivation of phase voltages, line voltages in on phase current and line currents in star connection as well as delta connection. These three questions are very important. Thank you one and all. Next class we discuss about the problems of two sections, that is third unit. To see this video, please subscribe DBS Talks.